Alrighty. Good afternoon, everyone. So today we'll be doing factorization, specifically for grade 10. You can still tune in for grade 9, but yeah, this will mainly be grade 10 level factorization. We also end a bit earlier, maybe 5-10 minutes earlier because of loadshedding, but yeah. So today we're we're first gonna start with some trinomial factorization, mainly because as much as you do it in grade 9, you definitely will do it in grade 10 as well, and also it will be harder. So usually with trinomials, first off, don't forget that the standard form must be in the form of ax squared plus bx plus c. That just means it has to be 3 terms where one is a square variable, one is a normal variable with no square, and one is a constant. So these ones, factorizing these are a bit easier because when we list out the multiples for the last number to determine what should go inside the brackets, the middle term is what we have to get to just by adding those two. So for the first term in each of the brackets, it will be x, because x times x will give me x squared. And then for the last term, it will have to be, well, 1 in this case, but the reason why this is because we need to get to plus 2x, and we can see that we just need to have 1 plus 1, that will give me 2. So how it gets harder in grade 10 is the numbers in front of each of the variables will change. Instead of being just 1, it'll be something that isn't 1. For instance, 3x squared plus 7x plus 2. Okay, so now with this, same thing still applies. It will still be 2 brackets. However, what goes in front of the x's now needs to change. In this first example, I'll do one with a prime number in front of the x, and remember that prime numbers can only have factors of 1 and itself. So 3 is a prime number, so that means one bracket must be 3x and the other bracket can only be 1x, because 3 times 1 will give me 3 and x times x will give me x squared. Now the method again for choosing what goes in the last position of our 2 brackets is still going to be the same, but there's another level we have to add to it. So 1 and 2 are our multiples, because 2 is also like a prime number, so it can only be 1 and 2. And we need to choose the multiples that add up to our middle term. But we can see our middle term is a bit bigger, it's 7x. So what we need to do is multiply each multiple by the number in front of your x's. So if we say 2 plus 1 times 3, that will give me 2 plus 3, which will just equal to 5. Right, so that's not the answer we want. Let's try it again. 2 and 1 are multiples, but this time let's say 2 times 3. So 2 times 3 is 6, plus 1, that will give me 7. And that is our middle term. So how do we substitute this into our brackets? You might want to immediately write just the 2 of them as is. That would be incorrect. You need to make sure that when you substitute it into the brackets, that after you FOIL it out, you get this result in particular. So we know that 2 has to be multiplied by 3, so it just has to go in the other bracket, because first, outer, inner, last. 3x will multiply by 2, and then 1 will just go in our first bracket, and they both will be positive. Right, so this is the first major change, or thing that you need to look for in grade 10, and particularly probably term 4, grade 9, where we will have a number in front of our first variable of x squared. If it's a prime number, and also this is why you want to try and remember those prime numbers. If it's a prime number, it can only be itself and 1, and that is a very important fact. So don't ever forget that. Prime numbers can only be itself and 1. Plus do another example, but this time with a non-prime number. Let's do 6 a squared minus 17a plus 12a. Not 12a, just 12. Right. So here we have a number, or sorry, an expression where the first number in front of our squared variable is not prime. So this makes it a bit harder, and the only way really to do this is with some trial and error. So we know that it has to be a and a. The problem is 6 can have two options. It'll either be 6 and 1 or 2 and 3. Right, so we'll need to choose carefully here. Let's not substitute that in just yet. Let's look at the multiples of 12. So if we look at the multiples of 12, it will be 12 times 1. Actually, not let me write it here next to it. 12 times 1, 6 times 2, and 3 times 4. Or 4 times 3, I just want to keep it in that order. Okay, so I'm changing the method to, or I'm changing it from writing it all on the side to writing it all underneath each of these. Again, when you do this on your own, you should probably do it on the side, on the right side of your page, just because that's your working out. Right, so I've listed all of my multiples for each the first and the last term. And the number we want to get to is negative 17. So what you need to do here is unfortunately just FOIL as much as you can and try and get to the right answer. Means for choosing numbers, try and start with your last term first. So by that I mean 12. So let's start with 12 first, and let's just say we're doing 12 and 1, and let's say 2 and 3. So yeah, when it comes to foiling out this, focus on the outer and inner parts, because we've chosen the first and last fine. Again, they're multiples, and 6 times 1 and 2 times 3 are both giving me 6. So we just need to make sure that our outer and inner works. So let's say 12 times 3. 12 times 3 gives me 36, and 2 times 1 gives me 2, and that's not anywhere close to 17. So let's try and avoid 12, because 12 will probably take us way over. So let's do 6 and 2. So now 6 times 3 will be 18, and 2 times 2 will give me 4. Remember, this is negative 17, and this is positive 12 here, which means then that both has to be negative for 12. So negative 6 times 3 will give me negative 18, and negative 2 times negative 2 will give me negative 4. That is still not enough, so let's discount that one. Let's do 4 and 3 now. Negative 4 and negative 3. Okay, so the same method applies. What's my inner? It's negative 4 times 3, which will give me negative 12. Actually, let's do that in blue. Negative 4 times 3 will give me negative 12, and negative 2 times negative 3 will give me negative 6. Okay, so negative 12 minus 6 gives me minus 18. So now we're even closer to our answer. So let's stick to 4 and 3, and let's flip them around. Oh, also, if you're grade 11, you can use the quadratic formula just to get the answer immediately. The thing is, when you write the answer, just don't forget that whatever answers you get from them, you have to invert the signs. So if you get positive answers, you need to write a negative answer inside the brackets. And you need to show the quadratic formula, but they'll only accept that in grade 11, not for grade 10. I know some grade 10s were taught the quadratic formula, but they only accept the quadratic formula as an answer in grade 11. Okay, so let's flip this one around. Okay, so 3 times, oh, whoops, sorry about that. That was that way down. 3, there we go, and 4. So negative 3 times 4, sorry, negative 3 times positive 3 will give us negative 9. And now 2 times negative 4 will give me negative 8, and minus 9 minus 8 will give me minus 17. So this means that the numbers that go in front will be 2 and 3, negative 3 and negative 4. So this one will just take a lot of trial and error. As for the marks though, it'll usually be 3 marks if it's just this on its own. But yeah, it's just going to take a lot of trial and error. Some things you can look for when trying to solve it. Take a look at 17. 17 is an odd number, so you probably don't want to do any multiplication or any multiple combination where you get an even answer. So saying 4 times 3 is 12 and 3 times 2 is 6, that's not going to work because we're going to end up with a positive answer. So you should rather try the negative or the uneven combination with 9. Right, let's do another one. Some example. Oops, I'm gonna do that. So negative 3 and negative 4. Right, so here we have 4m squared minus 12m plus 9m squared. So there is an easier way to do this one that's not going to take trial and error. It's the perfect square method. Importantly, you can only do this if your first and last term are perfect squares. Right? So 4 and 9 are both perfect squares. So if we want to get an answer for one like this, we need to just write down my first and last term individually. But make sure that, oh, oops, not n squared, just, there we go. Write first term and last term individually, and make your last term the opposite sign. So this is positive 9, so we want to write instead negative 9. What we then do is square root both and put the entire thing to the power of 2. What will this do? It'll square 4, which will be 2, and square m squared, which will be m. We will just say minus 3, because square root of 9 is minus 3, and that is this one fully factorized. It's a lot simpler. So if ever you see a situation where you end up with the first term as a perfect square and the last term as a perfect square, you can do the perfect square trinomial method. So you take the first and last, you write the opposite sign, and then you say the square root of each of them. Okay. So there's one more thing with trinomials, and that is trinomials with 2 variables. So I'll first do a simple example of 2x squared plus 2xy minus plus y squared. So if we have a trinomial where my first and last term are well, they both contain a variable squared. This means that most likely in each, or definitely in each of the brackets that we have here, the first term will contain this, that first variable, and the last term will also contain that last variable. And what you do after that is you just focus on the numbers. So in this case here, we both have 1 in front of each of them, so that'll be fine, and we have plus 2, so the answer will be x plus y times x plus y, or x plus y all squared. If you want, you can also apply the perfect square method here, where you square root both, and that will give you the same answer. But yeah, let's say you want to do that one. So what we'll do next is the sum and difference of cubes. So the sum and difference of cubes first off, it's called cubes, so we want to keep our perfect cube numbers in mind. So 1, 8, 27, 64. Oops. And those are the most common ones. Yeah. If you ever want to check what the cube numbers are, you can just say to the power of 3 in calculator if you're unsure of them, or cube root. That will immediately tell you whether or not it's a perfect cube. 64, 1, 2, 5, 2, 1, 6, 3, 4, 3. This is 5, 1, 2. 7, 2, 9. And then 1,000. Right, so this is all the perfect cubes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the perfect cubes until 10. I'm not asking you to remember all of them, but if ever you end up in a situation where we have two terms being added or minus, you want to try and first check if those numbers are perfect cubes. Another hint could be potentially the variable itself, because then variables must be a factor of 3 or a divisor of 3. So basically any number that can be divided by 3, your exponent has to be one of those. So it can be 3, 6, 9, 12. Any of those means that it's most likely going to be a sum or difference of cubes. So that's the first thing that we need to note about the cube method. It's sum or difference between two cubes, which means that this method, let's do a simple one, this method applies to both the addition and subtraction of two cube values. And so difference of squares, it had to be two terms being minused, where both of them are perfect squares, while sum and difference of cubes, it can be either added or minused, but they have to be perfect cubes. So the method for factorizing sum and difference of cubes luckily stays the same. It's going to be the same sort of thinking. It's just that what you write down is going to change slightly. So just like in sum and difference of or in difference of squares, we will have two brackets. However, this is a particular property about the second bracket in sum and difference of cubes that's really important here. So first thing we want to do is cube root both of them. Cube root both of your terms. This will give us the answers of x minus 2. So that's the first thing you want to do. You want to make sure that the sign that you put down in your first bracket is the same as the sign you started out with. So x minus 2, so x and 2, and a minus has to be in between them because that's what we started out with. Second step is you now can basically ignore the first question or the first part of the question, because what we need to answer the second bracket is this first one here. So what goes in the second bracket will be the square of both. So the square of x will be x squared, and the square of 2 will be 4. Note that these will always be positive regardless of what's in here, because anything squared, whether it be positive or negative, should give me a positive answer. So now what goes in the middle is the product of the two middle with the opposite sign. So x times 2 will give me 2x, and we have to put the opposite sign as the middle term. So the opposite sign will be positive, and that will give me plus 2x. An important thing to note about the second bracket though, this second bracket can never be factorized. It can't be factorized, and this is going to become extremely important when you do it in algebraic expressions and fractions. So keep that in mind. The second bracket of a sum and difference of cubes can never be factorized. So we'll do the same one, but this time with x plus 8, or x cubed plus 8. Let me actually write it a bit lower. Let's do a different number actually, plus 27. Right, so same method applies. We cube root both. You don't have to do the spot in blue, this is just my working out. I actually don't usually want to show this. X plus 3 goes in my first bracket. In my second bracket, we will get all the info from the first one that I just got. So we square both. That gives me x squared plus 9. And as for what goes in the middle, sorry about that, we multiply the two out. So 3, the product of them, 3 times x will be 3x. And we want to put the opposite sign as the middle term. Right, so the step goes as follows. Cube root both terms, and then for the first bracket that you got, square both terms, and that will be your first and last in the second bracket, and the middle would be the product of the two with the opposite sign. Okay. So, yeah, the method doesn't change. You just want to keep in mind your cube numbers, and again, just use a calculator to check if it's an actual cube number using the cube root function. If you don't know where that is, let me show you real quick. The cube root function is the shift of your square. That's the cube root function. And you aren't expected to remember all of the cube root numbers, but it can be useful when trying to save time. But rather get it right than save time. Right. So the way factorization gets harder in grade 10 is things will become more layered, and also they'll start using fractions. Now the thing with fractions is a fraction is still gonna be the same method. It doesn't matter. Actually, let me say that's 3 and this is 6. A fraction, the same method will still apply, but it will apply to both the numerator and the denominator. Right? So, is this a different sum of two cubes? We have 8 to the power of 6, so 6 is definitely divisible by 3. 3 is also divisible by 3, and 216 is a perfect cube number. 216 is this right here. So method still applies. So 8 to the power of 6. If we want to figure out what goes in the first bracket, we cube root both. I did it in blue. We cube root both. So 8 to the power of 6 will be 8 to the power of 3. Because remember, roots just say divide by what's ever on the root. And 216, the cube root of 216 will be 6. And the cube root of 8 to the power of 3 will be a. And we just say plus here. Okay, and then second bracket. I'm not really doing anything that I'm doing. I'm just doing the same thing that I always did. We're squaring, or that we did in the previous ones, we're squaring the first and the second term. So don't forget that when we raise something to the power to an exponent, it means the exponents multiply. So the second bracket will be a to the power of 6. Oh, oops, sorry about that. 6 divided by 3 is 2. Yeah, so we multiply the two exponents here, and that will give me a to the power of 4. And when we square an entire fraction, that just means the numerator and the denominator get squared, so that will give me 36 over a squared, and then the product of those two. So they don't care too much about the simplification here, as long as you have the correct thing, but I'll show the simplified version. So if we multiply a squared and 6 over a, don't forget that when fractions multiply, or rather when a number without a denominator multiplies by a fraction, you just have to multiply the number by the top. So a squared times 6 will give me 6a squared over a, and this will cancel out, meaning my middle term will be plus 6a. Right, so depending on what they are expecting from you, they could either want the simplified version. Just give the simplified version, because that's the best way to get the final mark. So make sure to give that final simplification there. Right, so don't be scared by fractions. Fractions, just whenever we factorize fractions, or even when we solve for x with fractions, just treat them as two separate parts to a whole sum. So work out whatever is the numerator, work out whatever is the denominator, and proceed like that. Forget about the fact that it's a fraction. That's not as important. Okay, so let's do some grade 10 examples of what you can expect from factorization for your exams. Right. So here we have the examples of an exam paper question of factorization. Excuse me. Sorry about that. Okay, so for the first one, we can see that it's a trinomial, but it has a number in front of the x squared. For the second one, it is a sum of cubes, but we have a fraction. And for the third one, there's a lot going on there, but it's worth 5 marks, and I'll show you why that is. So for the first one, actually, let me do that a bit better. Alright. Okay, so 2x squared plus 13x minus 24. If I want to factorize this one, this is a trinomial, so we'll have two possible answers, or sorry, two brackets as my answer there, where since we have x squared and x has to go into both, and 2 is a prime number, so one will definitely have to be 2 and the other one will have to be 1. So what goes in the second bracket, we need to determine that by listing all the multiples of 24. So 24, 12 and 2, 8 and 3, and 6 and 4. So that's all the multiples of 24. These are the only numbers that can multiply to give us 24. And what goes in the middle? The sum of them, but the middle is 13 and my first term is 2. So since my middle term is 13, let's just multiply 2 everywhere and see what happens. So 1 times 2, if we add up, or minus 24 times 2, it's not going to give me anything. 24 times 2, it's not going to give me cos 13, so let's ignore that. I should put a cross through that. Okay, so 12 times 2 is not going to work. 2 times 2 is going to give me 4, but if we add those two up, it's not going to give me 13, it's actually going to be just short, so that won't work there. With 6 and 4, 6 times 2 is not going to work because that'll be 12, and then 12 plus or minus 4 is not going to get me 13, and neither will be 4 times 2. So one thing to note about the middle term is that it's an odd number. So if that number is odd, that means then the sum of an even and an odd will give me a odd number. So the only place where that's possible is 8 and 3, because 3 is an odd number and 8 is an even number. So it'll most likely be 8 and 3, but let's see. 3 times 2. So 3 times 2 is 6, and 8 plus 6 or 8 minus 6 is not going to work. So let's instead say 8 times 2. And again, this is negative 12, so one must be negative and the other must be positive. So 8 times 2 is 16, and if we say minus 3, 16 minus 3 will give me 13. And my middle term is 13, which means the two terms I will be choosing is negative 3 and 8, but since 8 is being multiplied by 2, we have to put 8 in the bracket that comes after that, or the one that doesn't have the 2. Again, this is because of the FOIL method, specifically the outer part. And then negative 3 goes in the other bracket, and that one is now fully factorized. Right. So then the next one. Here is a somewhere. 1 over 8 x cubed plus b to the power of 9. Yeah, and it's worth 3 marks. So this is two terms, so we want to look at the difference or the sum of thinking. Is it perfect? Are they perfect squares? No. Are they perfect cubes? Yes. 8 is a perfect cube, and so is 1. Don't forget, 1 is a perfect everything. Perfect square, perfect cube. And also, more importantly, b, the exponent is 9, and 9 can be divided by 3, so that is a sum of cubes. So, sum of cubes, again, same method. The fact that it's a fraction doesn't matter. So the cube root of 1 over 8, remember when we root fractions, we just need to put the root over each of the parts. So the cube root of 1 will give me 1, and the cube root of 8 will give me 2. Now the cube root of b to the power of 9, we have to divide 9 by 3, and that will be plus b to the power of 3. Oh, and x we have to cube, so that will give me just x. That's a bit better. There we go. So now it goes in the second bracket. We can get completely from our first bracket. We're just using our first bracket, so if we want to get that answer, what we do is, again, we square each part. So If we square a fraction, again, it's just the top and bottom that you need to square individually. So the square of 1 is 1, the square of 2 is 4, and the square of x is x squared. We're just squaring each part individually. And b to the power of 3, again, this is a raised to the power of, so we need to multiply the exponents. So 3 times 2 will give me 6, so that will be b to the power of 6. Right, so then what goes in the middle is the product of the two, so a half x times b to the power of 3 will give me, oh, by the way, this, again, the last one is always going to be plus, because anything to the power of 2 will give me a positive answer. A half x times b to the power of 3 will just be a half x b to the power of 3. If you want, you can also rewrite in another form of x b to the power of 3 all over 2. Both is acceptable, they both are correct. One thing you need to now concern yourself with is the sign, and the sign will always be the opposite. And there, that one is fully factorized. So, again, the fact that it was a fraction didn't change the things you did. You just needed to make sure that you did it correctly to each part of the fraction. So don't forget that when it comes to fractions. If you're squaring fractions, it's just the top and bottom. Cubing fractions, top and bottom individually. If you put the root of a fraction, again, numerator and denominator individually, and you just work out like that. So the third one, bit of a way bigger question, we have a factorization by grouping. So this isn't something and I went too much into detail to, so we'll do another example of this afterwards. But factorization by grouping means you want to take parts of a sum and just maybe factorize certain parts that will help you to get a better answer. For instance, we have an A, we have a B and a B, we have an x cubed, x and x squared, and a non-x. So there's nothing that we've done really with x cubed and x squared in one sum, but we have the a's and we have the b's. So what we can do is look at each of these parts individually, and this is what I mean by factorization by grouping. We can group each part and factorize them individually. So if we factorize this part right here, what is common between them? It is a and x. X is common between them, a and x. So we can take out x as the common factor. So what do we left from this one? Since we'll be taking out an a, the a will come out, and since we're taking out an x, that leaves us with two of them. And we're taking the ax out of the 25, so we'll take out, or we'll be left with just the 25 there. This is where it gets a bit tricky, when there's a negative in front of this one right here. So we have two options. We can either change this around by putting 75 in front of 3, and then bringing the 3 over, which is fine, that will also work, or we can take out the negative. So you know what, let's not worry with taking out negatives. Let's flip 75 and 3b around first. So we say plus 75b minus 3b x squared. And now you don't need to show this step in particular of the rearranging. I just did it for ease, for the sake of the ease. Alright, so we can still work with these two individually. So what is a common factor between 75b and 3b x squared? Can 75 be divided by 3? So can 75 be divided by 3? Let's check on a calculator. Yes. Let me look at the screen. There you go. Okay. Yes, it can. So this means we can take out 3 as the common factor, and this is 3b. So we'll take out 3 as the common factor, specifically plus 3. As for the letters, only b is common, so we'll take out b as well. So that's simply with 25 minus x squared. Alright, so I can see why they started the sum off like this. Now we have a situation where we have a similar bracket, but we have to do a sign swap first. So let's keep the second bracket because it's some you usually want to keep the second bracket or the first bracket as is, and we change the second bracket. So 25 minus x squared. Let's flip that around by changing the sign of the thing outside. So now we can flip it around, and that is the answer there. Right, the other way you could have done it is take out -3 as the answer, or as the common factor, and they will be left with the same thing. But this now is not yet fully factorized because we have a common factor of x squared. So we can take out x squared minus 25 as the common bracket, and that leaves me with a x minus 3b. We're still not done factorizing. We need to do something with the x squared minus 25, and that is the difference of two squares. So that gives me x minus 5 and x plus 5 times a x minus 3b. Right, so it's still the same things that you've done before, but just with an extra step. And that is all that grade 10 factorization is, and also for grade 11. It's the thing that you've done before, there's just a little bit more to it. Whether that be a step that you have to do before, or maybe rearrange the sum around a bit. So if ever you're looking at a sum and you see that there could be an answer there, it's just that it's like there's a negative that's wrong or the order is incorrect. You can move things around in math. You just need to make sure that you move them around correctly, specifically when it comes to negatives, because that is the downfall a lot of the time where we move a negative incorrectly. Okay, so let's do some more factorization. Okay, again, this one looks simple. You could just take out 3 as the common factor. That's definitely correct. X squared minus 1. We've taken 3 out of 3x squared, so that only leaves the x squared. And if we take 3 out of 3, remember when we say take out of, we technically mean divide by. So 3 divided by 3 is 1. So the second bracket will be x squared minus 1. This is not the end of the sum though, because there is still another step of factorization. I promise you, if you're grade 10, this is going to happen. Your factorization is not going to end by one step. It will most likely continue into the next one. So x squared minus 1 is a difference of squared. So we square both, and we have 2 brackets for difference of square answers. So the square root of x squared will give me x, and the square root of 1 will give me 1. One will be positive, and the other will be negative. That one is fully factorized. Yeah, so you can maybe again look at the mark allocation as for how many steps. If it's 3 steps, it's most likely going to be at least 2 lines of work. So the first mark is the correct common factor, and the second mark is the difference of squares factorization. Okay, so here we have a squared plus a minus 2ab minus 2b. Right, so we can see that there's a lot of the same thing for the first two, like there's an a in both of them, and there's a b in the second two, so let's just take those a's and b's out from each of them. The first one we can take out, so for the first half, actually let's do something. Part we have this, the second part we have this. So again, this is more factorization by grouping. So we can take out a as the common factor, and this leaves us with a plus 1. And for the second one, we can take out a b, and we can take out 2, and specifically we can take out 2b. So let's take out minus 2b, Again, if you take out positive 2b, it's not wrong, but you just need to make sure that you go on to fully factorize it by doing a sign swap. But if you take out minus 2b, this leaves us with a positive a, again, because we're taking the negative out as well. And we take out both the 2 and the b, and this is negative 2b, and since we take out negative 2b, that leaves us with plus 1. So then the answer for this one will be a plus 1 as the common bracket here, and then a minus 2b as the second bracket. Alright, so again, this was another factorized by grouping question. With all of these, you just have to try and spot those similar or those variables that are the same in different parts of the sum. And that's again why it's called factorization by grouping, because you're taking one group of it. And the reason why I'm doing a lot of exam questions is because I really want you guys to see that it's going to be the same method over and over. It's just that you have to watch out for certain parts or different things in each of them. For instance, again, this is another factorization by grouping. Right, so we have 3x squared plus 3px minus 2mx minus 2mp. So usually in these ones, you want to try and look for the numbers that are the same. For instance, if you were to group let's say 2mp and 3px because they have p's, that's not going to help you because you can't really take out a factor between 2 and 3. You can, but you'll have to take out fractions, and none of us like working with fractions. So let's avoid that. So let's group 2 and 2, 3 and 3. So 3x squared plus 3px minus 2mx minus 2mp. So for this first group, we can take out 3x as the common factor. 3x, that leaves us with x plus p. Again, because I've taken out the 3, so the 3 comes out. I've taken out one of the x's, so the x remains. I've taken out the 3 and the x for the common factor, so only the p remains. Right, so here we have minus 2 and minus 2, so let's take out minus 2 as the common factor. And we have m and m in both of them, so let's take out m as the common factor. Right, and this leaves us with just the x, because we took out the negative with the 2, and just the p, because we took out the negative with the p as well, with that one. And now we have a common bracket of x plus p times 3x minus 2m, and that can no longer be factorized. Right. So let's go up a level. This was all grade 10 up, so let's do grade 11 factorization. Or rather term 1. Okay. Sorry for that, give me a second. Alright, so where the factorization will be used mainly, well, most likely be in the algebraic expressions part, and that's with amount of fractions. We're not going to do those ones today because I'm going to spend an entire day focused on both expressions and the fractions. But yeah. Oh wait, this one's okay. Never mind. This one's the same. Right, there we go. Note this is all under the factorization part, and again it's different from simplification because simplification is we're multiplying everything out. We want to write things as simple as possible. I'm not saying that you won't use factorization in those ones, but it's slightly different. Also, it's different in what you want to end up as the final answer, because factorization should end up with everything completely factorized, while simplification means that you can't simplify anything more. You can't group anymore, you can't multiply out anymore. Everything is as simple as can be. Okay, so for the first one we have 14x to the power of 7. 14x to the power of 7 minus 7x to the power of 14. And this one's only worth 2 marks. So it means that we'll probably only do one step or one line of work. So it is 2 terms and they are being minused, but they are not perfect squares, so this will not be the difference of squares. Right, 14 and 7 are not perfect squares. So we can take out then, or what we can look for then instead is a common factor. And 7 and 14 do have a factor in common, and that is 7. Right, if we look at the x's, we have x to the power of 7 and x to the 14, so they both have x to the power of 7 common. Again, whenever you're trying to find a common factor for variables, it's always about the exponents. So you usually want to end up choosing the smallest exponent, because remember, to the power of just tells us that it's the same thing how many times. So x to the power of 7 means it's 7, or sorry, means it's x 7 times. So we can take out x 7 times. So since we take out 7 from 14, that leaves us with 2, and since we take out x to the power of 7, the 2 stays on its own. We take out a positive 7, so that leaves the negative inside, and we take out 7, so it'll be technically a 1. And we take out x to the power of 7, so that leaves us with 7 more x's inside. And so the final answer will be 2 minus x to the power of 7. Again, only one line of work with 2 marks. Okay, so for the next, I'll just do a few more sums and then we'll move on to some expressions that use factorization, because factorization doesn't just happen in the factorized answer, it will be everywhere else as well. Right, so 2x minus 8x to the power of 4. We have 2 terms being minus, but 2 and 8 are not perfect squares, so we want to look instead for a common factor, and the common factor here would be 2. So, 2 is my common factor, and if you look at the x's, it's x squared and x to the power of 4, so we can take out x squared. What that leaves us with is, we completely took out the 2x squared, so that leaves us with 1, and we take out the 2, which means that 4 goes inside, and we take out x squared out of the 4, so that leaves us with x to the power of 2. This isn't fully factorized yet because we have 1, which is a perfect square, and 4, which is a perfect square. So then Also, x squared is a perfect square, so then we can do the difference of two squares. So the square root of 1 will just be 1, the square root of 4 will be 2, and the square root of x squared will be x, where one is negative and the other is positive. Right? So that's the thing with grade 10 factorization. It's going to use all the forms of factorization you did before. It's just that it's going to be more steps of it. Also, it will be things that you know how to do, but it will be disguised by either writing something overly complicated, or just by putting a whole lot of variables to make it harder than it actually is. So, for instance, like this one, we have 3 times a plus 2b minus 4 all to the power of 2 minus a plus 2b minus 4. So we have two brackets and they are the same, so we can just take out the common bracket. The common bracket of a plus 2b minus 4. So let's just take out the common bracket of a plus 2b minus 4. A plus 2b minus 4 as my common bracket, and that leaves me with 3 times, we only took out 1, so that leaves me with 3 times a plus 2b minus 4, and then we took out the entire bracket, so minus 1. This isn't done yet. Let's see if after we multiply everything out we end up with something else we can factorize inside that bracket. Plus 2b minus 4. So 3 times a is 3a, 3 times 2b is plus 6b, plus 6b, 3 times minus 4 will give me minus 12, minus 1, and that will group to 13. And that is your final answer. This cannot be factorized anymore. It may look like in the second bracket you can take out 3, but remember 13 is a prime number, so the only factors it can have will be 13 and itself. Yeah. So lastly we have a to the power 15. Oops. A to the power 15 minus 8. So we have two terms that are being minused, and we have 8, which is a perfect cube, but also 8 to the power 15, it is also a perfect cube because 15 can be divided by 3. So don't forget that the variables, the exponent must be able to divide by 3 for it to be a perfect cube. Okay, so 8 to the power 15 minus 8. It's different color, sorry. If we want to get the answers for some more difference of cubes, we cube root each part. So 8 to the power of 15 means we have to divide 15 by 3. So 15 divided by 3 will be 5, and cube root of 8 will be 2. And again, you just keep that sign. Now that we have the first bracket, we can ignore the start and the beginning, and we just work with this part right here. So we square each term. When we square an exponent, or raise to the power of an exponent, we have to multiply the exponents. So 2 times 5 gives me 8 to the power of 10, and 2 to the power of 2 gives me 4. Again, always positive, because anything squared gives me a positive answer. Then for we get the middle term is product of the two, so a to the power 5 times 2 will give me 2a to the power of 5, and for the sum and difference of cubes, the middle term needs to be the opposite sign of the first bracket. And again, this cannot be factorized. The second bracket right here cannot be factorized, it is done. Okay, so let's do another trinomial where we have a variable in both the first and last term. Put the marks here. Okay, so here we have 18x to the power of 2 plus 12xy minus 16y to the power of 2. We could try and factorize this as is. Again, if you get this in grade 11 for some reason, or if they told it to you in grade 10, you technically can't show that working, but you can use it to help you find the answer. You can use the quadratic formula, but again, they probably don't want you to do that. So we have 18, 12, and 16, all even numbers, so immediately it's tricky. We can divide everything by 2. Is there anything else we can divide it by? Can 4 work here? No. Can 6 work for all of them? No. And 8 won't work for all of them, so the only thing we can take out is 2 as the common factor. If we take out 2 as a common factor, that leaves us with 9x squared plus, also don't forget to write equal to, plus 6xy minus 8y squared. Right, so now if you want to factorize this one, if there is variables in the first and last position, it means that both terms inside your brackets will contain the variable. Right, so now we need to list all of the multiples for each of them. So for x, 9 is not a prime number, unfortunately, so we have to list all the possible values. For its multiples, it will be 9 and 1, 3 and 3. And I'm particularly writing it in where it will go when I write my answer, or underneath it rather, just so that I don't lose track of where I'm putting it. And for the other multiples, for 8 we have 8 and 1, 2 and 4, and that is it. Actually, let's say 4 and 2. Okay, so negative 8, our last term is negative 8, which means that one of the terms for 8 must be negative. So it's a lot of trial and error, but you have to do it this way. There's no other way really. So when we check for these answers here, we want to think of FOIL, specifically the outer and inner parts. So 9 times 1 will give me 9, and negative 8 times 1 will give me negative 8. Does that get me to positive 6x? No, it does not. So that probably won't work here. Let's try negative 4 times 3, which will give me negative 12, and 3 times 2, which will give me 6, specifically positive 6. Oh, we want to get to positive 6 instead, and minus 12 plus 6 will give me minus 6. So let's flip that sign around. Instead of saying minus 4, we'll say minus 2. So this means then that 4 times 3 will give me positive 12, and 3 times negative 2 will give me negative 6, making our sum here 12 minus 6 will give me positive 6, which means that for my brackets, I want to say that the two variables will be 3, 4, specifically positive 4, 3, and minus 2. Right? So these ones, they're a bit annoying to do, but you can do it if you just spend a bit more time with it. Again, another way you can potentially look for if an answer or if a multiple is worth pursuing is this is an even number here, 6. So 8 times 1 will give me an even answer, but 9 times 1 will give me an odd answer, which will be 9, and no matter how you add or minus that, you're not going to get to an even number. Let's do another one like that. Okay, so a to the power 4 minus 8a squared b squared plus 16b to the power of 4. Okay, so now we have way bigger numbers than, or sorry, way bigger exponents than what we're used to. But again, importantly, it's all just divisors of 2, so they still can work. 4 can be divided by 2 as well as 2, and the 2 in the a and b, and the 4 on top of the b can also work here. It can be divided by 2. The other thing is, a has the coefficient of 1 and b has the coefficient of 16. So we can use where's that? Oops, there's it. Let me find that. There we go. So what we can use is the perfect square method, where we write the two terms and we keep the sign over the middle. We have two terms, keep the sign over the middle, and square each of them. So the two terms we have here is a and b, specifically 16. So we'll say a to the power 4 minus 16b to the power 4, all squared and square rooted. And the reason why I'm doing this in white is that you can actually show this as you're working. So a to the power 4, square root of a to the power 4 will give me a to the power of 2, minus square root of 16 will give me 4, and b to the power of 4 square rooted will give me b to the power of 2, and that's all to the power of 2 there. And this is almost done. We can still do another level of factorization, because a squared is just a perfect square, as well as 4 and b squared, and they're also being minused, so we can do the difference of two squares for this one right here. So again, this is the perfect square method, while this is the difference of two squares. So we can say then a, and when I'm writing in green, you don't have to write yourself. It's actually a weird Pascal angle. So you know what? Before we do that difference of squares, let's instead write out what this actual sum will be. So this will be instead a squared minus 4b times a squared minus 4b squared. Okay. So a squared minus 4b will give me a perfect square, so that's a minus 2b, a plus 2b, and this one will give me the exact same, a minus 2b, a plus 2b, and we can rewrite this as a minus 2b all to the power of 2 because there's two of them, times a plus 2b all to the power of 2 because there's two of them, or even simpler, a minus 2b times a plus 2b all to the power of 2. I don't recommend that last one because it's not necessary. Okay, so this one's worth 3 marks, mainly because you'll only get 1 mark for this factorization here, and you'll get 2 marks for these final answers here. Yeah, so it's a lot of work, but that is how it'll work in this case here. So the reason why it looks like a lot of work is because it was just a lot of rearranging stuff. But yeah, again, look for the perfect squares in these complicated trinomials because that will help you immensely. Right, so sorry. Okay. Let's do some intro to simplification of algebraic expressions. So, factorization won't just be in the factorizing part of the question, it will definitely also come in at the simplify the following sort of questions. So like it'll be maybe a fraction, actually most commonly it will be a fraction, so yeah. Okay. So being able to identify different forms of factorization will be extremely important because it's also going to help you choose whether or not focusing on one part of a sum is even worth it. So, for example, this question right here. Alright. So, this is a fraction. The fact that it's a fraction doesn't mean anything right now. When we work with fractions, please again remember that a fraction can be split up into its numerator and its denominator. So what you want to do is focus on the numerator only and then focus on the denominator only, which will then probably lead to you having to work with the fraction. But the fact that it's a fraction doesn't mean anything for you. You still want to look for the factorization in it. And this is how factorization will be used in larger mark questions, and for majority of grade 10 and in grade 11 they won't even ask you normal factorization. They will be in this form most likely. Right, so p squared minus 18p plus 56. This is quite big because of the 56 for a trinomial. So let's just start with that. So I'll say equal to, let me actually do this on the side for the factorization. So this is also over p minus 4. And we have two brackets as my answer for that trinomial. So again, p squared, only p can go in the first part of the 2, while 56 can be 56 and 1. 56 divided by 2 is 28. 28 times 2. By 3 does not work. I think by 4. So 14 and 4. Okay, it's 6 and 7 and 8. Okay. So the model term we want to get to is negative 18, and we have positive 56. So since we have a positive answer, it means that either they both have to be positive or both negative. So since it's a negative answer, they both have to be negative. So minus 7 minus 8 does not give us negative 18. It actually gives us 1 short. Well, sorry, it gives me 2 short, which is negative 15. But negative 14 minus 4 will give me negative 18, which means my two brackets will be negative 14 minus 4. And now this is the first thing I want to point out to you in simplifying questions. Almost everything that is there in the question is most likely there to help you find or to help you cancel out. So we had p minus 4 in my denominator, which means that in a sum like this we'll probably have a p minus 4 somewhere in the numerator. So if you look at all of the multiples of 1, 2, 4 and 8, the only one that has minus 4 is this one. So that's the only one that we should try looking at. I'm not saying that it's always going to be that way, because it could appear in the second fraction, when we start doing more than one fraction at a time, but that is what you want to try and use to help you get the correct answer. So p minus 4 will cancel out with p minus 4, giving me the final answer of p minus 14. P minus 14. Okay. So all of the simplification questions will use factorization, especially simplification questions with fractions. Those will use it way more. So look for those factorizations. Right. So let's say we have something like this one. I'm sorry, it's a bit too big. Okay, there we go. X squared minus 16, x squared plus 6x plus 8. Again, they will just say simplify the following expression. Okay, so if we want to simplify this one, the first thing to do is get the actual factorization correct. Do not bother with the fact that it's a fraction. I'm going to keep on stressing this. Factorize first. Alright, so for the first one at the top, we have x squared minus 16. It's two terms, and they are both perfect squares, which means we can do the difference of two squares. So x squared minus 16 is factorize out to x minus 4 and x plus 4. And the bottom part, we have x squared plus 6x plus 8. That is a perfect trinomial. So that's just a trinomial. So we'll have two answers for the denominator as well. So the first term in each of the brackets has to be x, because we need to get the x squared, and 8 has the multiples of 8 and 1, 2 and 4. We want to get to 6x as the middle term. So how do we get to 6? 8 plus 1 does not work. 2 plus 4 does work. It gives me 6. So then our answers will be 2 and 4. But again, we had plus 4 in the numerator. We had to get that ourselves, but we still had it there. So again, use information that you had before, whether it be from factorizing or from the question itself, to try and help you, guide you to the correct one you need to focus more time on. So x plus 4 will cancel out with x plus 4, and this is just the answer of x minus 4 all over x plus 2. X plus 2, and you might be inclined to cancel out the x's. Please do not cancel out the x's here, because x minus 4 is one whole term and x plus 2 is another whole term. So you cannot cancel out just parts of an expression. You need to cancel out the entire expression, not just parts of it. So that's another common mistake there. So do not cancel out just the x's. You can only cancel out that entire part. Okay, next one is very similar again. I'm not going to do anyone with multiplying or addition just yet. We'll do that tomorrow. Yeah, we'll just do that along with tomorrow as well. Okay, so x squared plus 9x plus 14 all over x squared plus 11x plus 28. Now we have two trinomials. So again, 2 brackets as your answer there. Okay, so for the first one we have x in both of the brackets because we need to get the x squared, and we have 14 as our number and as our last term, which means the multiples for them will be, okay, let me do it a bit closer here, 14 times 1. Oh, you see that? There we go. Okay, so 14 times 1, 7 times 2. Does 3 work? No. Does 4, 5, 6? Nope. So it can only be these two. And we want to get to 9x as our middle term, and the only one that adds up to 9x will be 7 and 2. So 7 and 2 are our factors. They both have to be positive because we want to get to positive 14 and positive 9. Okay, so next we have x squared plus 11x plus 28. Again, 2 brackets because that's trinomial, where the first part will be x, as that's an x squared there, and now we need to list the factors of 28. So 28 times 1, we have 14 times 2, we have 3 does not work. Does 4 work? Yes it does. That'll be 7. So 7 times 4, does 5 work? No. Does 6 work? No. So the only factors that work will be 7 and 4, and we want to get to 11, so it has to be 7 plus 4. Oops. So our 2 factors will be plus 7 and plus 4, but again we had plus 7 in the numerator, so we probably should have spent more time looking at the 7 instead of the 28 and 14. So then this will cancel out, giving me the final answer of x plus 2 and x plus 4. So again, I can't stress enough, do not cancel this out. I don't believe anyone will take away marks, but there is a chance that there could be negative marking and you might lose some marks there. So just be careful of that. And also, they can use all types of factorization in these questions, all types. And again, the difficulty comes from not telling you which ones you need to use. Oops. Alright. So here we have x squared minus 3x minus 10. So the top one is just a trinomial again, and that's minus 10, which means that one of the factors have to be positive and the other one has to be negative. This is all over 3x minus 15. I'm not gonna let that just yet. Let's just focus on the top part. So we factorize the top part. The multiples of 10 are 10 times 1, 2 times 5. So again, it's negative 10, which means one has to be positive, the other has to be negative, and we need to get to negative 3. So minus 10 plus 1 is not going to work. Plus 10 minus 1 is not going to work, so we can discount that. How about minus 2 plus 5? Minus 2 plus 5 will give me positive 3, so it's very close to what we want. So instead, let's flip the signs. Plus 2 minus 5. Plus 2 minus 5 will indeed give me minus 3. So these are my 2 factors. So again, x and x in the first part, because we need to get the x squared, and for 10 it can only be plus 2 and minus 5, because these multiply out to negative 10, and these add up to negative 3. Alright, so the reason why I left the denominator empty is because I think there's some form of factorization that can happen there as well. We have 3 and 15, and if you think about 15, it can indeed be divided by 3, or in other words has 3 as a factor. So we can take out 3 as a factor. If we take out 3 as a factor, that leaves us with just the x, because we take out the 3. And if we take 3 out of 15, that will leave us with, specifically negative 15, that will leave us with minus 5. And again, this cancels out, giving us the final answer of x plus 2 all over 3. And that is your final answer. It cannot be factorized anymore. So, x plus 2 over 3 is my final answer. No other factorization and no other dividing. So I'll do 2 more examples of these sort of fractions. Okay. So we have x squared minus 9 and x squared plus 27. So I'm not even saying divided by, I'm saying and. Again, the fact that it's a fraction is unimportant. You first have to factorize. So x squared minus 9 is a difference of 2 squares. So we will have 2 brackets as the answer. The square root of x squared is just x, and the square root of 9 is just 3. So one will be positive and the other will be negative. Let's not write that down. So next we have x squared plus 3 plus 27. So that is a sum of cubes. This time we want to cube root each part. So the cube root of x to the power of 3 will just be x, and the cube root of 27 will just be 3. We want to keep that sign, and now we can ignore the first part and just focus on the second part. So the square, so if you want to get what's in the second bracket, we square each part. So that gives me x squared plus 9. And if you want to get what's in the middle, we have to multiply. We'll get the product of the 2 terms. So that will give me 3x. And the middle term will always be the opposite side. And that one is now fully factorized. So now we're using to make sure that we can cancel out correctly. And we can, because x plus 3 and x plus 3 are both entire brackets that we can cancel out, giving me the final answer of x minus 3 all over x squared minus 3x plus 9. And I chose one in particular because this is your final answer. I know it looks like the bottom part can be factorized out, but remember what I said, this second bracket here can never be factorized, right? So they cannot be factorized. If you want, I can show you the multiples of 9 is 9 and 1, 3 and 3. If we add 1, if we add 9 and 1, that gives me 10. Doesn't work out. We need to get to negative 3. If we add 3 and 3, does not work out. We can even say add and minus. So that gives me 0. Minus 9 plus 1 gives me 8. Cannot factorize to that one there. Alright, so the second bracket in a sum and difference of cubes can never be factorized. So what usually happens in a sum and difference of cube question that has factorization in, excuse me. Okay. No. Excuse me, just get this one out real quick. Here. So, oops. X cubed plus 2x squared plus 4x all over excuse me, x cubed minus 8. So for this one we need to now simplify as well. So for the top part we have x cubed, x squared, and an x. We don't have any form of factorization that works with that, so let's look for a common factor. They all have x's in common, so we can just take out x as the common factor there. So if we take out x as a common factor, that leaves us with x squared plus 2x plus 4. Okay, let's not work with that one just yet. Let's go on to the denominator. So x cubed minus 8 is a difference of cubes. So again, if we want to get the difference of cubes, we have to cube root each number. So the cube root of x to the power of 3 is x, and the cube root of 8 is 2. We'll say minus, we keep that sign for the first bracket, and for the second bracket, we can now just use this one. So we square both again, and that will give me x squared plus 4. And if we multiply the two of them, that will give me x times 2, which will give me 2x, and the second sign, or the middle sign, always has to be opposite. So now we have a situation where these two can cancel out, and this is where again that property is extremely important of that second bracket cannot be factorized out. So the mistake that would have happened here a lot of the time is people would try to factorize this numerator out. It cannot be factorized out either. Okay, so whenever we have these algebraic expression questions, try and start with cubes first, or at least focus on the cube part. Maybe write down the full factorization out somewhere on the side, and know that that second bracket cannot be factorized out. So this answer will be then instead x over x minus 2. And this cannot be factorized out or simplified at all. Again, because you cannot just cancel out the x's, you have to cancel out the entire x minus 2 term. Or expression, rather. Right. So, I think I'll do one more and then we'll end it here. Because we don't keep everyone just before load shedding. We'll do one more fraction one. Or maybe do it 5 times. Right. So here we have 3a times a plus b minus 4b times a plus b. So, this is again our factorization that we can do for each of them. The top is a common bracket. We have a plus b as the common bracket, which means we can take out a plus b as the common bracket, leaving us with 3a minus 4b. Right, so a squared minus b squared is a perfect, is the difference of two squares. So we square root both. We'll have 2 brackets as the answer. We square root both. Both answers go in, where one will be positive and the other will be negative. And if we want to cancel out, we can, because we have a plus b and an a plus b at the bottom, so we can cancel that out, leaving us with the final answer of 3a minus 4b and a minus b. And we cannot factorize this any further. We cannot take out anything between 3 and 4. Okay. Let's do one more grouping question, and then that will be the end for today. Okay, so AC plus BD plus BC plus AD all over C squared minus 2CD minus 3D squared. Okay, so for the top part, AC BD, BC AD, let's see if we can take out anything from the first two, AC BD. Can't do that, so let's move things around. Actually, before we move things around, let's focus on the bottom part, right? Let's do the thing that looks a bit simpler. So C squared minus 2CD minus 3D squared. So if we want to factorize this out, it is a trinomial. We just have variables in both square parts, in both first and last, which means that each part will be both C and D in each part. But now, the numbers that go in front of them, we need to make sure it's correct. So C must only just be C. That cannot be anything else because there's a 1 in front. So C times C give me C squared. While 3 is a prime number, so prime numbers can only have factors of 1 and itself. So 1 will be 3 and the other will be 1. Alright, and then how do we know what goes inside there? We have negative 2 as the middle term, which means then that when we multiply 3D out also, it must give me a negative answer. So one has to be positive, the other has to be negative. So let's say minus 3 and plus D here. So C times C will give me C squared, and 3D, negative 3D plus positive D will give me negative 3D squared, and minus 3 plus 1 will give me minus 2. Right, so the reason why I did that is because this is now giving me a little bit of a hint for what I should do at the top. So I know then that I have to get C plus D somewhere at the top here. So let's arrange things such that we have a C plus D. Here we have a C plus D, but the B is not, there's nothing common between them. So let's put the A's and B's common all together. So AC plus AD, close bracket. Actually, you don't do that here, just see it. Plus BD plus BC. And so all I did was move things around. Okay, so now we can factorize each part here. We can take out A as the common factor at the top. So we take out A, and that will leave me with C plus D. Plus, we can take out B. So that'll give me D plus C. Or you can also do the additive inverse just by writing it the other way around. It's gonna be the same thing. And we don't even need to do a sign swap because that's a plus and a plus. So let's instead say C plus D for that part as well. It's the same thing, and we can almost factorize. Almost, not yet. Why can we not factorize it? Because the C plus D is, for the top here, it's still part of an expression, right? It's still part of the plus B, and the CD is still part of the plus A. So let's factorize out the C plus D as the common bracket. And boom, we can factorize the C plus D out as the common bracket, and that leaves me with A plus B. And this is all over C minus 3D times C plus D, where we can now cancel out C plus D and C plus D, giving me the final answer of A plus B all over C minus 3D. Right. So the first part was just a grouping, a factorized by grouping, but they weren't written in the best order, and that's why I focused on the bottom part first, because now I knew that I can't get a 3 when I'm anywhere for the top, but I can get a C plus D somewhere at the top. So I just rearranged it so that we have the C plus D here, and here we have the D plus C. So let me just rewrite that in a better way again. This time as BC plus BD. There we go. Now we don't need to worry about a sign swap at all. So we can take out A as the common factor for the top and B as the common factor for the other part. And this will give me the common bracket of C plus D. With that common bracket, we can take that out as the common factor. And now we can cancel out the C plus D for the numerator and denominator. And that will give me the final answer of A plus D over C minus 3D. Right, so yeah, so that's all that I'll do for today. Tomorrow I'm going to do some, we're going to do expressions, but fractions and expressions all kind of meld into one thing. They can ask fractions in the expression part, and they can also ask expressions are part of the fractions. So yeah, tomorrow we'll just do a whole mishmash of all of this, and we'll do some with non-expressions as well. And that's particularly for grade 9 and grade 8, where you have to start multiplying things out. But alright, we'll end that here for today. Have a good day to no one person here. Thank you.